Today we're starting integrals. And the part we're going to talk about first are called Riemann sums. This is something completely new. So Riemann sums. Riemann. We're going to find the area of the shaded region. What shape do I have there? It is a square. How do I find area of the square? Length times width. So all I'm going to do is take the length times the width. 1, 2, 3, 4. This one is 1, 2, 3, 4. 4 times 4 is 16 units. That's easy, to find the area of a square. You still need this page? We're going to find the area of this shaded region. This one's different. What shape? Right triangle, which makes it even easier for us. How do I find the area of a right triangle? Yeah, what's the formula? No, that's the lengths of the sides. 1/2 base times height. My base is 1, 2, 3, 4, 5, 6, 7. My height is 1, 2, 3, 4, 5, 6, 7. 7 times 7, cut in half. It's 49 halves, or 24.5. You okay? How about this one? Find the area of that shaded region. You've never done this before. This shaded region, it is just the area underneath that curve. If I take this, that's just a normal function, right? What we're going to do is find the area that's underneath curves. That's good enough. These are called integrals. The area, yeah. The area of a region is denoted as, because I just did that, it messed this up. If you've ever seen this, it's like a long, skinny S. All right. That's the symbol for an integral. I have A down here, B right here, of dx. A and B are the limits of integration. In other words, they are my endpoints. That's my start, that's my end. A is called the lower limit, B is called the upper limit. D of x is called the integrand. What symbol this? The and symbol, the ampersand symbol. It just happens to be the font, that's the symbol. I changed the font. This is what we're going to do. If I wanted to find the area underneath this curve, just this piece right here from point A to point B, I'm only looking from A to B. I don't care that the graph might go over like this. The green, I do not care about, because the only thing I'm taking is the integral from A to B. So whatever's under A to B, that's what I care about. Without taking the formula for area, how can I find out what the area is of the square? Count what? Count the, let's see if I can bring this to the front. I can count all of the squares. 1, 2, 3, 4, 5, 6, 7. How many squares are there? There's 16 squares. Now for this one, it's a little bit different. Let me bring this to the front. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What do you notice? All right. That's not what I want. That's what I want. I have that rectangle. I have that rectangle. That one. That one. That one. And that one, right? And then I have all these little pieces. This piece and this piece make a whole. This one and this one make a. This one and this one make a. And then I'm left with half a piece. So if I counted up all these squares, there are 23 or 24 whole squares and then a half. 24 whole squares and then a half. For this one here, this is not a straight line, it's curved. If I wanted to find out what the area underneath this is, so I'm looking for the area from here to here. What can I do? What did I do for the triangle? I counted the squares. So I'm just going to do this. Instead of counting the full squares, I'm going to make little rectangles. I can put a full one there, a full one there, one there. Well, I'm going to put it this way. What am I doing? Making little rectangular regions. Okay, these are my bars. I have 1, 2, 3, 4, 5. I could find out how many regions I have, right? Find the areas, but it's these pieces right here that cause me a problem, right? This is where we're going to use Riemann sums. This can be very confusing. Let f be continuous on AB. You have a function from A to B. There are points, x0, x1, x2, x, however many points are in between. Be a partition of AB. For each k between 1 and n, let t sub k be an arbitrary number in x sub k minus 1, comma x sub k. Then the sum, f of t sub 1. Delta x sub 1. What does delta stand for? The change in, the difference. It's the change in. If I do all of them up to the t sub n's, the x sub n's, that's your Riemann sum. I know in words it sounds very bad. All this is saying is I'm taking the area of the shaded region, of that rectangle. Because how do I find the area of a rectangle? Of a rectangle. Length times width. My length is my height. My width is my change in my x. All I'm doing is adding up all of my rectangles. If I flip back for a minute, this would be like f sub 1 change in x1. This is my first rectangle. I find that area. Find the area of that one. Find the area of that one. Then I add them all together. It is not an exact answer because there's all these little pieces. But if you look on this one here, it's hard to see. Notice how the rectangle goes over. It's just estimated. You're going to have some that go under, some that go over the graph. Do you remember from pre-calculus when you add numerous things together? The summations. What that is the summations of f of t of k delta x of sub k from 1 to n. Yeah, all you're doing is adding up all the rectangles. Again, this looks more confusing than it actually is. What's that? Okay. The left sums is if you are taking it from the left endpoint. So if you look at this graph, this is what we did in the first one. We took the same graph and we just went from all the left endpoints. I took it from this point to that point. Wherever it was on this one, that's where I put the start of the rectangle at. This one's actually that's called a left sum. Everything's from the left. That's my left sums. The next one is going to be my right sums. All the right sums means is instead of starting on the left point here, I'm going to start on the right point. Do you see the difference? In the first one, I started from the left, and my little first rectangle was right here. That was my first rectangle. This one starts from the right. What do you notice about most of these squares, or the rectangles? They're outside. These ones were mostly inside. Here's the last one, it's the midpoint sums. All of these are the midpoints of the rectangle. So I could sit here and find the area of every rectangle and find out what the summation is. Here's the problem. We're going to let f of x equals x squared. And we're going to let the interval -1 to 2 be partitioned by -1, 0, 1, 3 halves, and 2. We're going to find all three Riemann sums. All right. For the left sum, I have the summation from, what's my starting point? Well, okay, I'm going to always start on my first step. Sorry. That's my first one. How many steps do I need to take? 1, 2, 3. There's 4 pieces. There will be 4 rectangles. This is 3 halves. That's 1. It's just the way it types. 1, 2, 3, 4. Okay, 5. Sorry. No. Never mind. You have to do your first one. Of f of tk delta of xk. From the left means I start at the left point. And the first thing I'm going to do is find f of -1 times by, how does it jump from here to here? Okay. What's the change from here to here? 1.
Oh, okay. She's so forgetful.
Sorry, my K's suck. Plus the next one's f of 0 times by, what's the change between 0 and 1? 1 plus f of 3 halves times, what's the difference between 1 and 3 halves? Or did I skip? I skipped one. No, I skipped one. Between 1 and 3 halves is, what's the difference? What's 3 halves mean? 1.5, so the difference is a half plus f of 3 halves times by, what's the difference between 3 halves and 2? 0.5. Another half. Do you understand what I did? All I did was first, it's going to be f of negative 1, f of 0, f of 1, f of 3 halves. The difference is in x, the difference in x, the difference in x, the difference is in x. F of negative 1. So I'm going to find out what f of negative 1 is. Negative 1 squared times 1 plus 0 squared times 1 plus, the function is f of x equals x squared. Plus 1 squared times 1 half plus 3 halves squared times 1 half. Okay? Only thing I did first is I just did f of whatever times the difference in x. Then I actually substituted in. You could do this in the first step if you wanted. No, because I'm doing everything from the left. Because you have to think, where's my left one? This point right here doesn't get a red dot. I don't create a rectangle on the last dot. Now I do the math. Negative 1 squared is 1 times 1 is 1. 0 squared, 0 plus 1 is 1. Or sorry, 0. I'm trying to hurry up. 1 squared is 1 times 1 half, 1 half. 3 half squareds, 9 fourths times 1 half is 9 eighths. I add this together, and I get 8 eighths, 4 eighths, 12 eighths, 12 eighths, 11, 9 eighths is 21 eighths. You guys can go.